Hi everyone, my name is Brooke and I'm a geologist. I haven't been able to make videos very consistently for a while now because I've left my job in Oxford and started a new job, oh hello cat, and started a new job at the University of Liege in Belgium, and that's where I live now. And it turns out moving to another country is quite complicated and takes a lot of time. So that's one of the reasons why I haven't been able to make videos very frequently. One of the other reasons is when I started my new project here in Liege, I then had to go out and do nearly a month's worth of field work in South Africa. I filmed a lot of that and I'll be making videos of it so you can watch them in the future and see what I'm up to. Moving around a lot like this is pretty normal for science academia. So I'm going to be here in Belgium for about 3 years working on this project. But it occurred to me that I've never actually talked about what kind of geology that I do and what my research is, because I'm obviously biased, but I think it's really cool and interesting, and it's not the kind of stuff that you'd see about normally in YouTube videos or even on the news. So what I'm going to do in this video is take you to work, show you the new lab in my office and show you some of the stuff I'm working on. Good morning, dog. And some of the cool rocks and tiny, very old fossils that I'm working with. So that's where I'm going now, walking from my house on the way to the bus to work. I get to walk past this, along this beautiful river where there are lots of cool birds like kingfishers and herons, and just this morning I saw otters. One of the cool things living in this part of Belgium is that you're on the edge of the Variscan fold belt from the Variscan Hercynian orogeny that formed Pangaea, and that means there's lots of cool geology which I'll be talking about in future videos. But as a taster, and to get you excited, I'm going to show you one of the things that I get to walk past every day and get to explore that's near my house. And that's this. So this is a massive fold. All the hills around here are huge folds from continental collision in the late Carboniferous and early Permian. And what we're about to show you now is a huge uplifted and folded Devonian reef. All of those bubbles on that bedding plane, so that was the seabed, like it was like that, now it's been lifted up like that. All of those bubbles are fossils of a type of creature called a stromatoporoid that was kind of like a sponge. So this is a huge sponge reef. It's been lifted up and folded like that. So the beds go up this side and then down that side. If you look carefully, like up here, you can see these bumps, and they're the reefs, they're the sponges. The sign of the leekmens. They really like the leekmen around here. They have a whole festival about them. And I kind of think the statue, these little statues are a bit weird, a bit creepy, but in a cool way. And you get to see this nice local Devonian limestone with the fossils in it. Yannick's lab. Cabinet of some curiosities. There's our corridor and the kitchen. It's my name badge. That's me. So here's my office. Spare desk. So this is when I have visiting students and visiting researchers. Geological timescale, so I always know when I am. So this is all Corentin stuff. Corentin was who had the office before me. He did loads of really cool work and found the world's oldest fungus. These are samples from South Africa. These are from Archean age rocks. So this is a komatiite, a special type of lava that doesn't exist anymore. big spiky crystals. What else have we got in here? Yeah, some 3.2 billion year old microbial mats. These are my pet algae and cyanobacteria. That's a secret. These are all my samples from Australia, all 1.4 billion year old sedimentary rock samples. Teaching awards there, voted by the students. This is another secret project from a 1.4 billion year old stuff. Really, really exciting. Some Jurassic Yorkshire stuff from back home. Pieces, some Precambrian stuff, teaching slides, some 1.4 billion year old volcanic ash, and my microscope for looking at hand specimens. Some geological maps of back home. And there's a fossil from back home on the North Yorkshire coast. It's a nice crinoidal limestone with a big Clammus valloniensis shell on it there. I also made a thin section of that, so I might make a video about that. I found that on the beach. I sat on it. It is my present of the second year Oxford students when I left, and it's a map of Arran, and they all signed it. So we went to Arran to look at the rocks there and show them how to do field geology. And this is a spreadsheet of my data of the fossils that I'm seeing. A piece of 3 billion year old banded iron, some 2 billion year old chert, the mysterious zebra stone, a lovely ammonite from back home, and some Cambrian ironstone from Spain, a fossil spider from America, and some mollusk shells, spirilla and argonaut octopus. More cool fossils and stuff. There's some 25 million year old oil, ammonite from Madagascar, crab from the Isle of Sheppey, shark tooth from the Isle of Sheppey, huge ammonite that I've made a video about, some fluorite that someone sent me from Derbyshire, trilobite from Morocco, orthocone from Morocco, Cambrian microbialite from California, it's a pegmatite with a huge biotite crystal in it from Scotland, some more Scottish rock there, nice. It's a late Triassic ichthyosaur vertebra I found when I stopped for a pee on a field trip to Westbury-on-Severn, and then a big clump of ammonites from Yorkshire there that I need to get prepped. I've got my little Burgess shale figures there. Look at the dorky eyes they've put on Pikea. Amazing. Right, so now we've had a look at my office. Sorry, I'm eating a sandwich. It's lunchtime. Let's go and have a look at the labs. First room we're going to look at is the microscope room, which has this cute little nudibranch on the door. This microscope is for looking at the fossils once we've extracted them from the rock and the macerations, and this one here is what the upside down microscope we use for extracting them from the dissolved liquid. I'll show you that in a second. This is for placing them on chips and slides so we can analyse them and look at them on different microscopes and analytical equipment. This is my shells, and these are the macerations. Maceration just means we dissolve the rock in a load of acid to get the organic stuff out, and that's what all this black stuff here is in this liquid. All those tiny little flakes are fossils, so there's a lot of them for me to go through there. This is the Raman spectrometry microscope, nothing to do with noodles. It uses infrared so we can understand what tiny little materials are made of, like our fossils. The two big blocks at the back are the big lasers, don't look at them. This is our FTIR microscope, and this allows us to use infrared again, looking at tiny little areas on the individual fossils themselves. This means we can work out what different parts of the fossil were made of. FTIR stands for Fourier Transform Infrared Spectrometry. I'll do a different video about it. This is the culture lab where Yannick grows algae and cyanobacteria to try and figure out how they might be able to photosynthesize on low light worlds like those that orbit the star TRAPPIST. There's his cultures there. Growing lots of little cool cyanobacteria and algae. Here's some of the university's world-class collection of the earliest land plants like Cooksonia. This is where the cat people live, so be careful. Also, you need to be careful because of this huge crinoid fossil on the wall. How big is it? Well, there's me for scale, and I'm about 195 centimetres. Here's the corridor of Paleontology. All of the lovely fossils there, lots of fish, big mosasaur skull there, I think that might be from Morocco. More early fish there, and a plesiosaur, looks like Jurassic. Skulls of Neanderthals and early humans that lived in the area during the Pleistocene and early Holocene. Lots of Pleistocene. More fishes here, Cretaceous fish and Eocene fish, and frog. And an ichthyosaur, Jurassic as well, I think. Lots of other odds and ends there from the younger rocks around the area. Big block of bricks and a nice dinorama. Yeah, see what I did there? Finally, we get into the invertebrate fossils, and there's a fantastic collection from the local Carboniferous, Devonian, Jurassic and Cretaceous marine rocks that we have in this part of Belgium. Unfortunately, I forgot to film all of the really cool trilobites and sea scorpions, but oh well, I'll have to go back and do them another day. Just some curios I found in the department. Big Carboniferous amphibian skull. Through this door is where the wild beasts live, and by wild beasts I mean the undergrads. They're not really that wild, to be honest. They've got this nice little area and some cool rocks and fossils to look at as well. And there's our nice outdoor bit. So I hope you enjoyed that little tour of the department and seeing what our lab was like and having a quick look at the fossil collections. On another day I might show you the other building where they keep all of the sedimentary and igneous and metamorphic rocks. Until then, latest potatoes.